Ladies and gentlemen, hello. Today we'll be talking about the sequences and how to find the nth term of your sequence. Okay, so before we start, you need to learn to differentiate between linear sequence, sometimes referred to as arithmetic, quadratic sequence, and geometric sequence. The differences come from the pattern and function of it. So look at this first sequence here. You have 3, 5, 7, 9, 11. You can see that the difference between them would be plus 2, plus 2, plus 2, and plus 2. Over here you found a consistent pattern of adding 2 to the term before it to get your next term. For quadratic sequence, on the other hand, you will see that it might start from the same number, but it progresses on to be a larger number at the end. So the difference here is plus 2, then plus 4, plus 6, and plus 8. Now, over here you have still not been able to find the consistency within your pattern, but if you were to look at the numbers at the bottom, 2, 4, 6, 8, you can see that if you add plus 2 here, you will get 4, 4 plus 2, you will get 6, 6 plus 2, you will get 8. And now that you found your consistency in your second layer, then you are able to differentiate and tell what comes next after this number. Then finally, geometric sequence. Geometric sequence is actually a ratio question. The numbers are a multiple of each other. Over here you have 3, 6, 12, 24, 48. You can already tell that it is a multiple of 2, multiple of 2, multiple of 2, and multiple of 2. Over here you wouldn't be able to find a consistent pattern if you were to use addition to it. Let me show you an example. If you find this is plus 3, plus 6, plus 12, plus 24, and you find the second layer is going to be the same thing, plus 3, plus 6, plus 12, and this goes on and on and on without ever stopping. So the only way to find it is to be able to identify that it is a ratio and a multiplication of times 2, times 2, times 2, and times 2. This is your consistent pattern. So these are your three differences: linear, quadratic, and geometric. So we want to find your nth term. Now, what is an nth term? An nth term is a formula which n in its continuation be able to find the term of its sequence without having to go up from one term to the next. Okay? So let me show you an example how to find an nth term. To find an nth term, look over here. First, you need to find the consistency within your pattern. So here is 4 plus 4 plus 4 and plus 4. 3 of your sequences all follow a different set of formula. For your linear sequence, the formula would be an plus b. So what is a, what is b? A will be your difference in terms, and b is your term 0. So how do you define term 0? Over here, this is your term 1, term 2, term 3, term 4, and term 5. To get your term 0, this number before 11, add 4, you will get 11. So this number is 7. Therefore, over here, your difference is 4, and term 0 is 4 as well. Term 0 is 7. Alright, we put these values into your formula an plus b. A 4n plus b. This would be your nth term. Okay, plus 7 is your nth term. Okay, so how do we use this nth term? For example, if we are looking for our first term, we only need to substitute 1 into your n. 4 times 1 plus 7, you would have gotten 4 plus 7 is 11. Your first term is 1. If you're looking for your fifth term, 4 times 5, substitute 5 into your n, plus 7. This is 27. As you can see, term 5 is 27. Okay, how about if you want to find for term 100? Your 100 term, you're not going to slowly add them one by one, plus 4, plus 4, plus 4 until 100. Instead, you substitute this 100 into your n. 4 times 100 plus 7 is equals to 400 plus 7, 407. Therefore, we know that term 100 is 407. Now, let's look at another example over here. 1, negative 5, negative 6, negative 7. As you can see, this is a descending order. 1 to 5 is minus 6, minus 6, then minus 6. So now for this question, A, the difference is actually negative 6, and B is again term 0. So what minus 6 becomes 1? 7 minus 6 equals to 1. So term 0 is 7 again. Alright, now we put this back into the formula once more. Negative 6n plus 7. This is your nth term. Okay, now if you want to check your answer again, let's say this is term 1, right? That's just now term 2, term 3. Okay, if you want to check your answer, just put any number into it to check. Let's say we want to find your third term, which is supposed to be negative 11. Negative 6 times 3 plus 7. This will equal to negative 18 plus 7, negative 11. So what would the term 100 term be? Term 100, put it into your formula. 6, negative 6, remember your symbols, times 100 plus 7. Negative 600 plus 7, you will have gotten negative 593. So this is how you use your n term. Alright, and the linear sequence formula is an plus b for your n term. Okay, moving on to your quadratic sequence. Your quadratic sequence, just like your quadratic equation, is an squared plus bn plus c. Now, doesn't this look familiar? Isn't it almost the same as your quadratic sequence where it is ax squared plus bx plus c equals to 0? Alright, now look at the difference here. For your quadratic sequence, like I mentioned just now, you're supposed to have 2 layers of difference. So let's find out the first layer here. The difference between 12 and 5 is 7. 12 and 25 is 13. And 25 and 29 is 25 and 44 is 19. Right? Now this is your first layer difference. Your second layer is supposed to be consistent. Over here it's not consistent yet. 7, 13, 19 is still just numbers. But what we're looking for is consistency. So 7 plus 6 is equals to 13. 13 plus 6 is equals to 19. This is where you have your consistency in your quadratic sequence. Now, for you to find your n term for your quadratic sequence, you actually need to follow these 3 formulas. 2a is equals to your second difference. 3a plus b is term 2 minus term 1. A plus b plus c is term 1. Alright, this is supposed to be term 1, term 2, term 3. That's all we're going to need. Okay, second difference, 2a equals to second difference. 2a is equals to your second difference. This is supposed to be your, this is your first difference, then this is your second difference where it is consistent. So 2a equals to 6. From here, you can solve your only unknown. A equals to 6 divided by 2, which is 3. Okay, now that you found A, move on to 3a plus b formula. 3a plus b is equals to term 2 minus term 1. Term 2 minus term 1 is equals to 7, right? Okay, so 3a plus b equals to 7. A, we've already found from our previous equation over here. 3 plus b is equals to 7, right? So 9 plus b equals to 7. B is equals to 7 minus 9, which is negative 2. Now you found b, okay? And finally, you want to find c, which is from a plus b plus c, which is equals to term 1. A plus b plus c equals to term 1. Term 1 over here is 5, okay? A we found out was 3, b we found out was negative 2, then plus c equals to 5. Look, we always solve the unknowns that we've already had, then only we use it. So 3 minus 2 3 minus 2 is 1, plus c equals to 5. So therefore c is equals to 4. Now that you have a, b and c, we have to simply substitute it into your formula of an plus b plus c to find your n term. N term is a 3n square, b, which is plus negative 2, which could be written straight away as negative 2n, plus c, which is plus 4. So this will be your n term for your quadratic sequence. Okay, now you might think that this formula is a bit hard for you to understand, for you to remember, but let me show you how do we derive this formula from. Okay, as we know just now, if you're looking for your first term for an square plus bn plus c, you're supposed to substitute 1 into your n formula. Okay, so for your first term, we can safely say that a 1 square plus b 1 plus c will be your term 1. Am I right? For your second term, you're substituting 2 into your n formula. A 2 square plus b 2. Oops, this is not supposed to be square. Hold on. A2 b2 plus c is equals to your second term. Then for your third term, a3 square plus b3 plus c is your third term. A4 square plus b4 plus c is your fourth term. Okay, then we simplify it over here. A1 square, which is a, b1 b c, a2 square, which is equals to 4a plus 2b plus c. Then substitute, solve for everything. Third term is 9a plus 3b plus c, and 16a plus 4b plus c. This is actually our quadratic sequence. Am I right? For our quadratic sequence, we know that there is supposed to be 2 layers of difference. So for your first layer, you're going to use term 2 minus term 1. 4a minus a is 3a. 2b minus plus b is, your difference will be 3a plus b. This is your difference between term 2 and term 1. Term 3, 9a plus 3b plus c minus 4a plus 2b plus c. You're supposed to get 5a plus b. And subsequently, 16a plus 4b plus c minus 9a plus 3b plus c. You're going to get 7a plus b. Now, this over here is supposed to be our first layer difference. First layer difference, right? Then we know that this is inconsistent yet, but we know our second layer is supposed to be consistent. Therefore, we use 5a plus b minus 3a plus b. You're going to get 2a. 7a plus b minus 5a plus b. You're going to get 2a again. Just like any quadratic sequence, your second layer will always be consistent. Now, look back into our question just now. 5, 12, 25, 44. First layer was 7, 13, 19. Second layer, which is the consistent layer, is supposed to be 6 and 6. So therefore, your formula 6, which is equals to 2a. 7 is equals to 3a plus b. And then finally, 5 is equals to a plus b plus c. We got all of this by substituting our number term into our formula without solving a, b, c first. Alright, So from here we can say 2a is your second difference. 3a plus b, we only got 3a plus b from using term 2, which is 4a plus 2b plus 2c minus a plus b plus c, term 2 minus term 1. Okay, and finally a plus b plus c is term 1, as we can see here. 2a second difference, 3a plus b, term 2 minus term 1, a plus b plus c is your term 1. This is exactly the formula that we need to solve your quadratic formulas. Okay, then again the working is as we have done over there. 2a equals to 6, a equals to 3, 3a plus b equals to 7, 3, substitute a in. You have to do it in this sequence. You have to do 2a equals to second difference. You have to solve for a first, because over here you have only one unknown. Over here you have two unknown. You can't start from over here, which you have 3 unknown, and you have neither of it at the moment except for term 1. Okay, you have to do from this way onwards. So maybe you can take a minute to pause this video and have a look at this formula before we move on to our last sequence. Our last sequence over here is your geometric sequence. Geometric sequence formula is a multiplied by r to the power of n minus 1. This arguably is your easiest sequence. If this comes up for your exam, you should be thanking and praising the Lords. Alright? So what is a, r, and n minus 1? This is for you to find your n term, right? A over here is supposed to be your first term, and then r is the ratio of your sequence, your ratio. Okay, so let's look over here. Just now we know that geometric sequence is a multiplication of each other. So 4, 8, 16, 32. Can you see the pattern? The pattern is supposed to be times 2, times 2, times 2. Okay, so this is actually your ratio. Substitute everything into your formula. 4 times 2 to the power of n minus 1. Now this would be your n term. As simple as that. Remember to bracket them, and you are not allowed to write it as 8 to the power of n minus 1, because 2 to the power of n minus 1 multiplied by 4 is definitely not 8 to the power of n minus 1. You can't multiply them in. Just leave them as this. This should be your final answer. Okay. Now over here you can see another example. Example 2. Oops. Example 2. 10, 5, 20, 2.5, 1.25. Okay. This, as we can see, is a descending order. Now you might be tempted to say that this is divided by 2. Divided by 2. But in geometric sequence, you are not allowed to use the division. Instead, what multiplication can we use to make 10 to 5? This is simply times 1 over 2, times 1 over 2, times 1 over 2. 10 times 1 over 2 is 5, 5 times 1 over 2 is 2.5, 2.5 times 1 over 2 is 1.25. So following your formula again, a is your first term, 10 for you to find n term, yeah. 10 times 1 over 2 to the power of n minus 1. Just leave n as it is. Okay, then this would be your n term for geometric sequence. Now this is the 3 sequences that you guys will be tested for, and if you were to be able to follow the formula and understand the formula, it would be no problem at all for you to finish these questions. Alright, so that is it for today. Thanks, bye.